Hello, 8th graders. It's day 16. We're going to do one-step inequalities today. For your inequalities, we're going to treat these kind of like we do an equation. On this example here, I'm going to go ahead and, put in my line right there, and I'm going to do my one-step inequality. For this one, whenever I get x by itself, I'm just going to have to divide both sides by 3. And x, this is the less than symbol. X is less than 4. So what that means is, whenever you have an inequality, is that anything less than 4 will work in my original inequality. So if I were to put, say, a 2 in for x. So up here in my original one, 3 times 2, is that less than 12? And you find out that yes, 6 is less than 12. Works out. If I were to put any other number that was less than 4 into my inequality, it would still work out. But let's look at what happens whenever I put a 4 in there. 3 times 4 is less than 12, and 12 is less than 12. Well, 12 is not less than 12. 12 is equal to 12. So that does not work. So what this solution says right here, actually should have circled that, is that anything less than 4 makes this inequality true. Okay, so I've got 2 more examples up here. This is still just one-step inequality, so I only have to do one thing to each one to get an answer. In my first example right here, getting x by itself, instead to get rid of this 3, I'm going to have to add it. It's being subtracted right now, so I'm going to add 3 to both sides. And my answer is x is less than or equal to 7. So all values less than or equal to 7 is going to make this original inequality true. On this one, I have a fraction here and it's being added to x, so I'm going to subtract 1/5 from both sides. Whoop. Greater than, x is greater than 2/5 minus 1/5. So 2/5 minus 1/5. My denominators are the same. I don't have to worry about doing anything with them. I can just subtract the tops. 2 minus 1 gives me 1, and my denominator stays the same. So x is greater than 1/5. Okay, lastly, and this is an important one to remember. Remember that we're just solving these the same way we do with equations. But here's the difference in this example. Okay, this is still a one-step inequality. Negative 7x is greater than or equal to 14. So to get x by itself, I'm going to have to divide both sides by negative 7. Okay, negative 7 over negative 7 gives me a positive 1, so x is, I almost did it myself. Super important to remember that if you are going to divide by a negative number whenever you're doing inequalities, you have to flip your inequality. So instead of being greater than or equal to, now it's going to be less than or equal to. And 14 divided by negative 7 is negative 2. So just keep that in mind as you're doing these. Solve them just like you do a regular equation. But if your last step to get x by itself is to divide by a negative number, you have to flip your inequality.